So, Velamani sir, later you will take screenshots, right?
Yes, sir. I'll take that.
Okay, and you can put it in Team BMSIT. Okay.
Yes, sir. Yes, sir. Definitely.
Okay, sir. Principal sir is trying to log in. The moment sir logs in, we'll start, sir.
Yes, sir. Yes, sir. Of course.
Good morning, one and all.
Good morning, ma'am.
Good morning, sir. Principal sir has joined. Good morning, sir.
Yeah. Good morning to you.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Once again, on behalf of Department of Civil Engineering, I welcome one and all to this August gathering. I take the pleasure to welcome our beloved Principal Sir, Dr. Mohan Babuji and Sir. I also welcome Vice Principal, the Dean, the head of various departments. I also welcome our resource person for today, our founder HOD, Dr.Aravind H Bhashyam Sir, my fellow colleagues, my technical staff, all the participants to this function. I'm extremely happy to share that today, due to the collaborative efforts of Eco Paradigm, Department of Civil Engineering, BMSIT, and Engg, for this FDP, we have more than 600 participants. And this has only been happening because of the efforts put by Velamani sir and Manish. And of course, the topic which has been selected by you, the theme of sustainability.
Okay, sorry.
We had Sustainability Development Goals 2020. Before that, 1987, we had the Brundtland Commission. Much before that, we had Mahatma Gandhi speaking about sustainability. But somehow down the lane, we have forgotten the concept. If we go back to our relics, our epics, all the ancient civilizations, sustainability was practiced. So I sincerely believe that today's effort to have an FDP on sustainability aspects in civil engineering will reignite a strong balance between civil engineering industry,
Thank you.
ಇಲ್ಲ ಸರ್ ಗೂಗಲ್ ಕ್ರೋಮ್ ಓಪನ್ ಮಾಡ್ಕೊಂಡು ರಿಜಿಸ್ಟರ್ ಮಾಡಿ
ಇಲ್ಲ ಬರ್ತಾ ಇದೆಯಲ್ಲ ಇದು ಯಾವುದು ಇದು ಐಫೋನ್ ಅಲ್ಲಿ ಬರ್ತಾ ಇದೆಯಾ
So with these few words, now I request our beloved principal sir, Dr. Mohan Babuji sir, to
ಇಲ್ಲ ಸರ್ ಅದೇ ಕನೆಕ್ಟ್ ಆಗಿದೆ
ಯಾವುದು
BMSIT
ಇರಲಿ ಬಿಡಿ ಟೇಕ್ ಇಟ್
sir, principal sir, now I request you to inaugurate, sir. Welcome to our FDP, sir.
Yeah, good morning, Rajesh. Good morning, the faculty and staff of Civil Engineering, BMSIT, and all the participants from across the country and probably even beyond the boundaries of this country. Good morning once again, and welcome to BMSIT. Hope you're all very safe, secured, your dear and near ones, your family, friends, everybody is safe, I hope. Wish you continue to be safe. That's more important to me. Of course, this COVID-19 is something that everyone needs to be bothered about. The kind of panic it is creating, the kind of havoc it has created across the world. But at the same time, we all appreciate the opportunity it has thrown up to us to take up. In fact, the world over, the movement has come down, transportation has come down, pollution has come down, people have started talking to each other online, largely. And one such great benefit that we have because of this is the current FDP itself. In fact, we are able to reach out to a huge gathering like you all, possibly running into hundreds, which otherwise would have been very difficult for us, unless if this were not to be the situation. If it were to be in-person kind of meeting, possibly we could have accommodated about 50 to 60 of you in the campus, but now we are able to reach a large gathering, and experts can also speak to all of you. That means a larger the benefit. But on the other hand, we are missing out on the physical one-on-one kind of communications, interactions, feedback, seeing each other's expressions, feelings, and so on. That's the loss that we are incurring because of this. But anyway, let us utilize the opportunity as it has come to us. And I must at the very outset congratulate the Department of Civil Engineering for having taken up this very important, very relevant, very current topic, that is sustainability basically. Sustainability and the concepts of sustainability, relevance of that in modern day civil engineering activities, right? And the kind of trends that we are seeing over there. This is what they are going to talk about, and this is what all the speakers who have been lined up to share with you. In fact, sustainability is not a new word. In fact, we all have seen how our ancestors and forefathers actually maintained their environment so good, and they handed over to us such a beautiful world, beautiful globe, beautiful earth. In fact, all that was possible for them because they were living very close to the nature. And the activities and the attitudes that they had in them were very friendly to the nature. Not much of the damage they were causing. Not that they were not living happily and comfortably, they were. But the rate at which they were consuming the resources, natural resources, was much lesser than the rate at which the Mother Earth could replenish it back. That's how the globe was green, beautiful, very clean, sumptuous water, anything that they wanted was available largely. But today, in the name of development, in the name of progress, in the name of high quality of living, high standard of living, the rate at which we are depleting I would say plundering, forget about depleting, plundering the resources that are offered by this Mother Earth, the rate at which we are plundering it is much, much, much higher than the rate at which the Mother Earth can rejuvenate or replenish. And possibly if we continue this kind of an attitude, we don't know where we are going to end up with, and we will be giving a very barren land for the generations to come. This is a very serious cause of concern, and all of us must be worried about it. And that's why I said this is although it's a very old topic, but it is very current now. Okay, it's very important that all of our teachers, all of you, will be disseminating all that knowledge that you gather about sustainability to your circles, so that even a small change that we're able to bring, this particular FDP is worth it. Of course, this concept, although we are discussing at a higher education level, I believe that this concept must be not just be taught, but must be practiced at the very lower level of education itself. Possibly from the very childhood itself, this concept has to be inculcated into students, and possibly our curriculum of the lower levels are doing it, but practice is not happening. Even the children who study it don't see that happening in the external world, and we are all responsible for that. That means they're in a dilemma, right? Whether the curriculum, what is given to them, is right, or what is being practiced outside is right. They're in a total confusion, and this inconsistency may actually tempt them to drift towards what we are practicing at the moment, and possibly they will join our fleet and probably spoil the world further. I believe that we need to work on changing our attitudes, reorient ourselves, readjust ourselves to the concepts of recycle, reduce, reuse kind of a thing, which you all know very well, and to make sure that we conserve on all possible resources to the maximum possible extent. Although we talk many times of best use of resources, even best use of resources can also loot this world unless the consumerism or that kind of an attitude comes down. Consuming attitude comes down. We know that everybody, in fact, earlier we used to say one car per family at the most, but today a family will have 3 or 4 cars. Just an example, like. And even this time of, probably you all would have seen the kind of water bills at your homes now because of COVID. Water bills are shooting up like anything. That only indicates how much of water we are all consuming. It is in thousands of kiloliters every one of us is using. Okay, we can come down on those aspects by appropriate use of the resources that are available to us, and help ourselves by helping this globe to replenish itself. That can be possible only if we reduce on the wastages and efficient use of the resources, and also minimize the so-called luxury, minimize the so-called essentials. We can work towards the basic needs first. Okay, this is what we need to do. I'm so happy that this kind of a FDP is planned by our people, and Department of Civil Engineering has always taken the lead in these kinds of activities. I'm so happy about that. And my own former colleague, Mr. Aravind Bhashyam, is the speaker, if I'm right, the first speaker. I'm very eager to listen to him and also meet him personally, but not because he's no longer at BMSIT at the moment. Okay, and he's such a great person, such a great resourceful person. I'm sure that all of you would benefit by his personal experiences in one of the major projects of the world, if I'm right. With this, I would conclude my introductory remarks. If even if 10% of us take 10% of what is taught and implement 10% of that in the real life, that would be a big contribution to this globe. Thank you very much. All the best. Good takeaway for each one of you. Bye.
Thank you, sir. Your words were inspiring, and I'm sure that this has set the pace for today's FDP. I would like to inform all the participants that under the stewardship of our principal, our campus is green and sustainable. There are so many stewards who are also helping us in such an occasion. And one great steward is Pravinjit sir. I also welcome Pravinjit sir. Department of Civil Engineering has a MOU with Eco Paradigm, and let me be very happy to tell you that Department of Civil Engineering has been very active under the stewardship of Principal Sir, my fellow colleagues, and support of Pravinjit Sir, that we have been successful in conducting effective participation, effective programs. Recently, we concluded a webinar expert lecture series on structures, where again Dr. Aravind Sir was one of our resource persons. In today's FDP also, we have Aravind Sir, we have experts from NIT, IIT, we have Pravinjit Sir himself, and so forth. Also, my dear friends, I'm very happy to share that BMS Institute of Technology is probably the only institute who has conducted an online skill enhancement program for the technical staff of Civil Department. It is only because of the support of our Principal Sir and the potential of our colleagues and technical staff. With these few words, I once again thank Principal Sir, and now I humbly request Pravinjit Sir to speak a few words. Thank you, sir.
Thank you. Thank you. Thank you.
Thanks.
Thank you. Good morning, respected Principal, Vice Principal, Dean, staff of Civil Engineering, BMS College, all the guest speakers and the students. A warm day to you. Well, we are living in a strange time, and I think it's a good time to just step back and talk about sustainability, which is the topic of the workshop, 5-day workshop. Now, if you know, in 2015, we had this Sustainable Development Goal, SDGs, which are 17 in number. No? And finally, if you bring down all that, it will come finally and rest down to technological sustainability, financial sustainability, social and environmental sustainability. Now, what happens as typical engineers, we always look at technical sustainability as something which we do. Every time we try to better what we do, that's something which is normal, it's expected. Financial sustainability is inherent, I would say, because that's how the world moves. So between these two, what has happened is the social and the environmental has actually taken a hit. So our water is polluted, earth is polluted, and of course air is definitely polluted. You know the situation in water in Bangalore. Being in Bangalore, you know what is the situation. Water is scarce, water is polluted, air is polluted. Delhi and is the situation in Delhi, and forests are dwindling. So these are something which, as engineers, and primarily being civil engineers, if you don't look into this aspect, as we all say, we have only one earth to live, and if that is something which we can't protect, a simple virus like this, a small tiny thing which you can't even see, can bring humanity to the knees. No, so as civil engineers, what can we do? We should think about waste minimization. One, pollution control, resource efficiency. So, which would mean resource efficiency means trying to use as much of recycled aggregates, designing something which is called low embodied architecture, solar passive architecture, where you don't need artificial systems to actually cool or heat a building, making the indoor air quality better. So all this is part and parcel of a civil engineer's aspect. Of course, some amount of cooperation is required from the architectural department, because these two, for whatever reasons, it has been split into two separate subjects. Actually, I would personally see it as one. We are just two sides of the same coin. So unless we work together, this would not lead to a proper. So what you see in Bangalore, or for that matter anywhere in the world, you see completely glazed buildings, and these glazed buildings trap heat, especially in tropical countries like us. Is a good idea in Western countries, but in India and other tropical countries, it's not a good system. So you trap the heat, and then you bring in artificial air conditioners and centralized ACs to cool it down. Then you try to bring in. So you look into any software company, you will have lots of CFLs and LEDs glowing. See, what you've done on technology is advancement in using low energy systems, getting the same light with minimal cost. But why do we need something like that when you can actually have natural sunlight? Look at the COVID situation. They're asking everybody to keep the windows open. Even in a hospital, the windows have to open, ACs have to shut down. This is the natural way to control what you call pathogens and viruses and things like that. So have fresh air. Somehow see if you can influence your architect brothers in modifying the designs, so that it is you orient the whole thing in a particular direction which is completely sustainable. No. So if you, again, everybody was talking about our Indian culture. Now, it starts with, there's something called a Shanti Mantra, and the Shanti Mantra does not really devote itself to any particular god, but what it says is peace to the earth, peace to the trees, peace to the animals, peace to water, peace to everything, sun, moon. So what it means is peace is not blessing them; it's trying to live in harmony with these elements, which actually are the cause for us. No, so once you extinguish them, you are not there. So human being is a small micro this one factor in this whole earth, but we are responsible for all these troubles. So when you look at waste, 40% to 50% of the waste produced in the world is through civil engineering activities. So which means, and the energy consumption is also 50% through civil engineering. Anything we build consumes energy. So can we design thinking where we can reduce this waste generation? Can we reduce the energy consumption and water consumption? So recycling water. So you don't need a law to make us do something where we are supposed to do. No, it is something. It's your own self protection. So sustainability is something of survival of humanity. It is nothing. It's not a big thing. You want to live, you need to practice a sustainable living. That's what I would think. And I think over the next 5 days, you would be seeing a lot of examples and directions. It will give you a new vision on how, as civil engineers, we can look towards sustainability. I mean, beyond, it should move beyond words, and it should become part and parcel of our practice. There are a lot of good examples, and I think as the days pass, over the 5 days period, I think you will see many such things. I personally look forward to the interactions. Thank you.
Thank you, sir. It was a pleasure hearing to Pravinjit sir, who's an environmental steward and has backed very good projects with the government of Karnataka, and he's doing really good for our state. One more such steward is Dr. Aravind Bhashyam sir, who is the founder of our department and has set the pace and tempo for which the vibrancy and dynamics that we are working. So now I request Dr. Velumani sir to speak few words about our FDP, and also welcome our resource person, Dr. Aravind sir. Velumani sir, please.
Thank you, Rajesh sir. Good morning, all. Today, it's my pleasure to take over the session to introduce about this program and to introduce about the first day's session speaker. And first of all, I would like to express my sincere thanks and to our beloved principal, Dr. Mohan Babu, and our head of the department, Dr. Rajesh Gobinar, who are constantly motivating us to do the things in different manner. And I welcome all my faculty members who gave their constant and tremendous support all over the program in the initial stage and also in the present stage. First of all, I like to inform that this program was lively streamed in YouTube channel because more than 650 participants have been registered for this program, and this program contains participants nationally and across the nation. Also international participants were also participating. So in this juncture, I would like to share this information to you all, and I would like to say that this program, sustainability, sustainability aspects and recent trends in civil engineering, especially a tag which is called as the future scenario. The future scenario. Okay, so sustainability, we know that from the primary things, if you look at that, we the civil engineers are the basic providers for the third basic need providers for the human society. Okay, so we are providing shelter for our human society. For that, we are consuming the natural resources and other resources like anything. So in the present scenario, it is becoming a viral topic, how to reduce the consumption of natural resources in our civil engineering sector. So for example, can I say that if you want to get 1 kg of cement, for its production, as we know that it liberates 1 kg of carbon dioxide in the atmosphere. So this is just one small example which is a trigger to ensure about the safety of our environment. Okay, so in this aspect, we conclude this topic will be our best topic for the faculty development program: sustainability aspects and recent trends in civil engineering, the future scenario. So that I want to share that we have also had association with Eco Paradigm. So I thank Praveen Jit sir for mingling with us to conduct this program. Thank you, sir. And so regarding this, I think that this program will be a great input for the practice of sustainability aspects in the recent trends also. So that I want to inform that we have framed this topic based on the sustainability development goals at the international level, which is framed in the year September 2050. So the goals have started in the name of Envision 2030 internationally, so that the year started from 2016 to 2030. This sustainability development goals will be achieved. So I think we have displayed the logo of the sustainability development goals as our logo to insist the importance of sustainability. So with this, I conclude about the program. So now it's my duty to introduce today's speaker, Dr. Aravind Bhashyam. Dr. Aravind Bhashyam completed his bachelor's degree from BMS College of Engineering and did his PG degree in civil engineering from IISc Bangalore and completed his PhD from IIT Madras. Dr. Aravind Bhashyam, after his studies, he started his career as a scientist at Structural Engineering Research Center, Chennai, and he himself involved in the development of intelligent systems for the analysis of transmission line towers. And Dr. Bhashyam later moved on to the industry and has worked with various design organizations also at the various levels in and across India, which includes idea and riding consulting engineers United Kingdom MSCEB Bahrain, Randhill, Malaysia, as head of structural engineering division for a period of about 22 years. And he involved himself as a chief structural engineer in various prominent projects and remarkable projects like Petronas Towers in Malaysia, Taipei 101, Tajura Housing Libya, Light Rail Transit System Malaysia, Baspa Dam, Vishnu Prayag, and Hydel Plant, and many more projects like this. So upon returning to India, he joined in MS Ramaiah Institute of Technology, and there he served as associate professor by involving him in various departmental activities in the period of 2011 and 13. So Dr. Bhashyam later joined as HOD, head of the department in civil engineering at BMS Institute of Technology in the year of 2013 to 17. And now he is presently working as professor at Christ University in the Department of Civil Engineering. He is also, moreover, he is also a member for various professional organizations like ASCE, ICI, ICE, IEI, etc. And Dr. Bhashyam has to his credit more than 30 publications in reputed peer-reviewed journals. So with this introduction, I conclude my speech and let me hand over the session to Dr. Aravind Bhashyam.
Good morning. Am I audible?
Yes, sir. Good morning, sir.
Good morning. Thanks, Dr. Veluvani, for your introduction. Thanks to Principal Dr. Mohan Babu. It's really nice. I saw you at least on the video.
Okay.
That was a good thing. As you rightly pointed out, we have plundered the earth. There's no other word, I think. Also, one more thing I would like to highlight is our soil is also depleting. In the soil, in the sense, the fertility of the soil. See, imagine that, the studies that have conducted so far have indicated that if we don't take care now, India will transform itself into a desert within 20 to 22 years. It's a very alarming situation for us. Imagine that if we have to feed such a huge population and if we have to import food from other country, where we will be. So yes, our generation was responsible for this. So we are trying our level best to rectify whatever damage that we have done to this earth, Mother Earth. So with this introduction, I thought I will start off with the presentation on sustainable aspect of the tall structures. Is my presentation visible to all?
Yes, sir, it is loading now.
It's loading.
Okay. So, a tall structure, how can it be sustainable? As Pravinjit pointed out, we need a lot of air conditioning systems. We need mechanized system for water, for humidifying this. Now, without that, how can a tall structure be useful for humankind? That is, so the tall buildings were not. The new ones. The present they were there in the 19th century. Because of the demand for the space and limited availability of that, we were forced to go in a vertical direction rather than in a horizontal direction. Now it has become a worldwide phenomenon. Now, if you look at this, initially the tall building started as an economical solution, and later on it became a symbolic identity of the cities, just to prove that I am much better than you. Now look at this. What made it possible? The tall buildings were made possible only because of the innovations in elevators, advances in steel making, advances in heating and ventilation system, air conditioning system, and electrical system. So all these things, the technology played a role in uh, in putting out this kind of a tall building across the globe. Now, if you look to the key paper of Ken Dalton on the sustainability, he said towards more sustainable tall building mean about achieving a mutual beneficial balance between environmental, economic, and social issues. This is called a triple bottom line approach. Now, I don't have the graph right now to show you. If you really build a structure, a tall structure, without taking this sustainability into account, and later on, if you want to add on to that, the cost will be enormous. You can't even dream of doing that. So it is good to look into the sustainable aspect of the design when you start planning for this. I will take one example of that, Taipei 101 later. Let's see what exactly you have about it. Now, we also hear about the green buildings, and they're more of a sustainability trend. What exactly is that? Now, many of the architects now agree that we are now looking at the having a greener buildings, and even clients also agree that they want to have economical and environment friendly buildings. And one good thing that has happened now, after a long time, that government has relaxed that timber can be used in construction, and the farmers can grow commercially timber for this. This is a very important step. If you look through all our ancestors, whatever they have done, they had basically they have used timber. They were very friendly with nature. Now it is we have brought in all kinds of things like steel, concrete. Now we are even going further. We want to bring in all kinds of smart materials also here. So all these things are happening. So how do we take care of all these things? Say that we want the building to be green, we want the building to be sustainable, but at the same time, I want to use the latest technology. I want a humidified atmosphere inside my tall building. I want excellent air conditioning system. I want a fast elevators inside. So all these things, how it is possible when you have on this? If I look through this, a simple thing, what is a green building? According to the World Green Building Council, is a building that is designed to construction and operation, reduce it or eliminate the negative impact and create a positive impact. Now, if you look through this, you have energy, you have air quality, you have material, you have site, water. All these things are contributing for your development. And when you are trying to do that, I must not disturb the land, I must not disturb the water body around that. At the same time, I must not play around with the energy around us. So if I have to do that, then I need to have a healthy, comfortable, durable, energy efficient, environmentally responsible building. I need to look into it in a different angle. That means I should be efficient in using the energy, water, and other resources. Just now, principal pointed out that the water bills are shooting up. That's what happens when you stay at home, when you have no control on the water, how it's being used. See, even every drop of water matters to us. Now, look at it. Look at ourselves. We are now running on for to get the drinking water. I don't know how long Kaveri can supply water to the state, to the Bangalore city and surrounding areas. Because if you really look through the Kaveri has not touched the ocean for a fairly long period. I don't know how many of you are aware of it. About 430 kilometers of that river has dried up. Now, where are we now? Are we going to use this? Or are we going to look for another source of water? The way we are using building or where you are constructing it, the way we are depleting the groundwater resources is very alarming. So where are we going to? The way we are doing things is really making the things go out of hand. We have no plans. We have no kind of a policy in this, say that this is how we're going to conserve the natural resources. So if you look into all these things, then probably you should find a way, probably you can find a way how best we can reduce the negative impact of whatever that we have been doing. That means reducing the waste, we are trying to bring down the pollution and also trying to reduce the environmental degradation. So what is the sustainable development? What exactly it means? The Brundtland Commission was the one which gave the meaning for this. It said development that meets of the needs of the present without compromising the ability of the future generation to meet their own need. This is a questionable one. If you look through our country, we have already depleted the environment, or we have depleted the natural resources. So our future generation, I don't know what they're going to get. That is what it is. So if you look at it, it has three important factors to it. One is the economic, other one is social, and the environmental. All these three play a role in making something sustainable. So when we look at it, we have to make sure that uh, anything that we choose will be sustainable. Now, don't get me wrong, I'm taking steel as one of the things because it has, I mean, when compared to concrete, it's slightly better in terms of environmental friendly sort of thing. So, steel, I have 40% of resources come from recycling. The manufacturing conditions, the process visits, and a controlled environmental impact. Material durability is there, and you have a high recycling rate. Now, you can ask a question: can concrete not be there? Yes, it is possible, but we have not had any kind of what is called as a sustainable work in terms of using recycling the aggregate, recycling something. Cement, once it is used, I cannot recycle it. It's gone forever. And if I have to produce cement again, I'll be emitting carbon dioxide into the atmosphere. So if you look at the construction phase, now look at the COVID, how you have social restriction. You can't have, you need to have certain distance between the workers. We need to have a certain distance between the engineers and the workers. And you need to have a certain, maintain a certain distance between all these things. Under such circumstances, probably prefabrication and steel is the solution for us, and what is called as the on-site manufacture. If you look through this, this is very important. Probably going forward, we may be looking more towards the steel and the prefabricated structure. If you look through this, recently I was been to UK, I saw that most of the underground work station that the work being done is through the digital work. Even construction sites have started using digital work. So what happens is now even construction is moving towards the digitalization. This is what it is. So now, as a student or anybody who has messed it out, you see that now the building information modeling plays a major role in civil engineering. So civil engineering cannot be separated now probably from this computer science that is going to invade into civil engineering, and it will play a dominant role now. So when you come to this design and service life, if you look at the reduction of the weight of the structure, you have to create versatile spaces. You are looking at the longevity and robustness of the steel component, and simple incorporation of the renewable energy resource system cannot is also possible with steel. Now, yes, steel needs maintenance. That's where it takes a major hit compared to concrete. It needs regular maintenance. That is one of the drawbacks of the steel structure. Now, end of life is easy to dismantle and reusable or recycle. So if you see that, steel plays an excellent role in case of a sustainability. Now, if I look at this structural scheme, the material used, the resources efficient, site planning can be efficient, energy can be used efficiently. I can come up with excellent structural system for that. It's non-pollution. From all this angle, steel appears to be a good one from the present situation. Now, when you look at the sustainable tall buildings, So what are the design criteria that you have for this? Now, there are three parts on the three heads. We'll discuss it, then we go into different criteria. One is the ecological sustainable design. What does it require? It requires a sustainable site, it requires water efficiency, it requires energy and atmosphere, requires materials and resources. And and then you have economical sustainable design, which is the efficient use of the resources and the low operating cost. And socio-cultural sustainable design has an indoor environmental quality and innovation in design process. Now, if you look to the first one, ecological one, what are the design criteria that you have? Sustainable. I'm going through this, the basic things. It is protection to the natural habitat, improvement in the urban areas, effective use of the construction site, creation of transportation and parking system, selecting the land for appropriate for the residential density, production of food, reducing the heat inland effect. All these things come under sustainable side. Then you have water efficiency. Then you have energy and atmosphere efficiency. Then you have material and resources efficiency. All these things are addressed. So you will have the various sources now available to meet your ecological thing. Now, when you come to the economical sustainable design, we have ensuring the source of efficiency of recyclable building materials. I'm also giving the section under which this falls into the criteria. I'm not very sure whether India has this code, but it's there in the United States. And selection of the building materials that can be used for a long term. Then you also have the low operating cost, where you provide energy and resource efficiency in manufacturing, and also you have the reduction in transportation costs the site by selecting local building materials, and you're economically designing the building with the cost analysis. And it comes to socio-economical one, what you have, the third criteria, creating the appropriate indoor comfort condition. If you look through our ancient or go to any of the village or look at the buildings in Bangalore, old areas of Bangalore. Some of them are still there. Even my ancestral house is still there. You can see that the comfort that you have. We never had fan or a fridge till 1980 in our house. That's how it was. That's how the interior of the house was. It even in summer, we never felt the heat, and in winter, we never felt it was so cold inside. It was so comfortable. That is indoor condition. But unfortunately now, with so much of development taking place around our house, it's no longer like that. We are forced to use our thing. So this is what is changing everything. So then ensuring the quality of indoor air, yes. When as a child, I do remember all these things, that the kind of surrounding that we had and the kind of atmosphere we had around outside, and used to climb trees, play there, and all sorts of games. But now it is virtually impossible to do that. And we lived with the nature. There were a lot of snakes and other animals around that. So we were part of it, and every day used to watch it and go. So that's how it was. We were so friendly with the nature, but later on we lost that contact. Now, avoiding the building materials containing the toxic substances, that is very important. Preventing the pollution. So these are all the comes under the indoor environmental quality. Then innovation and design and process, that is the one that is also covered by SCSD2. So we have all this creating the visual connection to the outer environment, designing the building which uses less energy. All these things are there. But how far are we using it? Now, the question that comes to your mind is, okay, all these things existed. Have we used it anywhere? Is there any tall building which is sustainable or it has followed the sustainable design criteria? There are a lot of buildings which have followed this. I have taken two examples of this. So let me tell you what is the thing. So one is just the Bank of America Tower. This is now it is in New York. Its height is 365.8 meters. There are 58 floors. It is certified LEED Platinum. The start ended in 2004 to 2009. And it's a composite construction. It has a reinforced concrete core and a steel frame. Now look at this. ESD, there's a green roof method being applied to the tower to decrease the urban heat inland effect. Wastewater is stored and used in an appropriate field. All of the building materials used in the construction of the tower are supplied from a distance maximum 600-800 kilometers. Steel used in the carrier system is obtained by recycling the scrap metals. Significant part of the electric energy of the tower is generated by 4,600 kilowatt power generation system. So nowhere we have tried to disrupt the nature. Everything that's been done is tried to be within that zone. Next, if you come to the energy aspect of it, the energy and source efficiency was provided by selecting recyclable materials that can be used for a long term for the construction of a tower. Even when you choose an architectural material for architecture, even that has a role to play. So we also choose that. We see that how much energy that it consumes in order to cool down or heat up or something. See, that is an advantage of the BIM. So even before you can construct, you can specify the material, and then you can evaluate what is the energy, that is embodied energy of that. And then you can decide whether that material is useful or not for your sustainable design. Next is the fresh air entrance to building is provided by means of air filtration system and sustainable building materials that do not, does not contain any toxic material, whether it is used in indoor or external. So these are some of the things that have been incorporated into the design way back in 2004. Okay, that's in United States. The second one is Taipei. This is from 1999 to 2004. So here the water need of the tower is reduced to 20 to 30% by using a recyclable water. Plants can be irrigated by the rainwater was selected in the landscape design. Rainwater is collected and used for to irrigate the plant and the toilet. 16 kilowatt hour energy can be generated using solar cells. Heat gain and loss is decreased by 50% by double glazing facade system. Glazing facade system application. Now comes to the energy part of it. Tower has some part of its energy need by means of the solar cells. Energy cost is reduced by decreasing the energy consumption by 30%. Economical sustainable design is supported by keeping the source consumption under control as well as energy. Later on, we will see what are the challenges that we face in building this Taipei 101. Now it's called the Taipei Financial Center. Original, the Chinese still calls it the Taipei 101. So here, in order to make the structure safe, certain things have to be introduced. I will talk about it a little later, but still the structure is sustainable. And not only that, it has withstood the typhoon and strong earthquakes also. So that way, from every aspect, this building is sustainable. Now, the other one is the Times Square building, again in New York. This is 183 meters tall. It has 40 floors. It's again LEED Gold certified. And here again, same kind of rainwater collection system and recycling system. All these things have been incorporated. In addition to that, sun shading is also used for the external wall to prevent harmful effects of the sunlight that contribute to reducing the energy consumption within the building, because it tends to heat up and you need greater effort to cool it down. And we have used high performance facade components in the external wall and optimize the heat gain and loss. And the construction materials do not affect the human health negatively, were used in indoor areas also. Now, if you look through all these buildings that we have, we already knew the concept of sustainable design. Now, see, this was in 2007 to 2010, Taipei from 1999 to 2004, and this building is from 2004 to 2009. So that means if you have built something in 1999, you must be aware of sustainability, the aspects of it. Okay. Now, if you look through this, the other one, that is the Hudson Street building, that is again in New Jersey. This is 2001 to 2004. This also has, it's not LEED platinum, it's LEED certified. So here also we have used all the necessary sustainable design aspect into this. That uses the water efficiently, and it has economic limitations determined by means of the cost analysis, and construction materials do not have any toxic materials, and therefore you see that every other thing that we have used here has has adhered to the standards adopted in the United States. Now, is it possible to make every building sustainable? Yes, it is possible. All tall buildings can be made sustainable. Now, let's go through the challenges of Taipei 101. What we had, how were you able to do that? Now, on one aspect, you have uh, this it is for them it is very auspicious 101. So the Chinese technology renamed as the Taipei 101. It's formerly called the Taipei World Financial Center. It's a landmark of the super tall skyscraper. Till Burj Dubai was built, this was the tallest structure. This is in Jinki district of Taipei, and this is owned by Taipei Financial Center. It has multi-level shopping mall adjoining the tower houses and hundreds of stores, restaurants, and clubs. Now, if you look through this, the social environment of this, it has a mall, it has houses, stores, restaurants, and clubs. You have water consumption, then you need to have some kind of a air conditioning system inside, and also you need to have some way to see that the atmosphere within that is suitable for the human environment. So automatically your sustainability comes into play. What did we do here? Now, if you look at Taiwan, let's try to understand the certain things about Taiwan. It is, yes, close to the mainland China. You can see that on the left-hand side map. And on the right-hand side is the enlarged view of Taipei. On one side, you have this Philippine Sea in the south, and then you have Taiwan Strait. This is which is experienced typhoon at any point of time, and it will experience earthquake at any point of time. On an average, it experiences maybe in a span of 10 days, at least 10 to 12 minor earthquakes. So this is seismically very active zone. Second, from the wind point of view, from the cyclonic stream, from the typhoon that you experience, the gale speed can go beyond 135 to 140 miles per hour. I'm not talking about kilometers; it's miles per hour. So such a huge thing is that, and you can see the location of Taipei, which here. So it is prone to all kinds of typhoon and earthquake. So now we are building a tall structure here, and that should be sustainable. Not only that, it should be able to withstand the typhoon and the earthquake that is experienced. So it's a tremendous challenge. How are we going to do this? First is for a short building, if you look at the structural design aspect of it, generally for a short building, your strength governs the design, gravity load is predominant. When it comes to the intermediate one, your strength and drift governs, and gravity and the lateral loads also to a certain extent. But when the building becomes tall, its drift, the building motion governs the design, and lateral load becomes predominant. So you can just give it a simple example here. I just have a height of the building H. Weight is W. It has some wind forces acting it, and there is some base moment. Now, if I increase the height or double the height, I can see that the drift is multiplied almost 16 times, and your base moment increases almost 4 times that. So you can see the impact of the height of the structure on the base moment as well as the drift. So height was the major factor that we had here. It had to first, when we started the design, it was not supposed to be a tall building. What was needed was to support the floors, shaft for the elevators, space, stable space for mechanical, electrical, plumbing, and fire, etc. Now, what happened was when the Petronas was built, and then the people there, Taipei Financial Center said, why not we make this also tall? Because your economic height, then once you have to make it tall, your economic height is decided by the rent that you get out of the floor. That means the rent of the added floor that you get should be greater than the cost of the added floor. So, which was, and also in Kaohsiung in Taiwan, that's another town, it has 85-story TC tower that was tallest building in the island of Taiwan. Now, the major demand from the project investor was that they wanted this to be the tallest building in the world. So its height got increased. So, and the projected office space was 200,000 meters square based on the individual floor area, and general office layout as per the standard led to the 101. Now, this is generally that what happens in the design. When you're doing something else gets added on because somebody gets the idea that why not we make it this way, and somehow I find an investment for that. So what happens is your criteria will change. Now, how are we going to address this? The height has increased, and this region is prone for typhoon, this region is prone for earthquake. At the same time, I have to keep all the other costs within the reasonable limit, at the same time meet the standards of the lead. What do? So they added again another 200,000 meter square area for podium surrounding the retail space and the basement parking. Next, second challenge was the foundation. They have a soft rock beneath for 40 to 60 meters of clay and colluvial soil. Groundwater is a 2 meter below the grade, and extensive investigation was carried out by ScenarioDay technology that's based at Taipei. So based on that, we said, okay, we'll have a slurry wall, 1.2 meter thick, surrounding both towers and the podium. It's 47 meters in depth, cut to the groundwater and provides the embedment varying from 21.8 to 23.5 meters. Each podium column bears a single 2 meter dia drilled pier socket, 5 to 28 meter deep. And the podium slab is resting it will have the buoyancy effect to prevent that we have necessary dead load on it. That's the way the podium slab is resting on that. Okay. So I'm not getting into too much details into the foundation aspect of it. Next one was we have a single pier that permitted top-down basement construction. I hope you know what is top-down basement construction. Top-down means I don't start from the foundation. I start from the roof, then I go down, and finally I build the foundation. So this is the top-down construction. What was the advantage of this? The mall could be opened much earlier than the tower, so that the investors can get a certain amount of revenue from the mall. That's the reason why we resorted to top-down construction, so that malls could be finished earlier. And then you have a mat thickness varying from 3 to 4.7 meters that transfers the load from a discrete columns and the shear wall to the distributed pattern of 380 drill pier of 1.5 meter dia, space 4 meters in a staggered row. We have used steel as a main frame system, but we have used concrete also within this. We'll see it's a composite construction. Okay. The advantage of this that the floor that is cast was braced and the perimeter wall and the story excavation was carried out beneath the slab, while superstructure framing was erected at the same time above the slab. So both the works could go on simultaneously. Now, as I said earlier, steel, it always comes from a shop, cut to the size, it's already been machined. So it has come from the fabricator shop, we come here, one brought here, and it is assembled here. So the construction would be faster. Second, the podium could be opened a year before the tower so that that space is available for them to rent it out and they can earn the investments on this. Next was the tower shape. So C.Y. Lee is the architect, and he is very well experienced in the designing of the tall tower. Now he came up with the shape of a pagoda, that is something which has a narrower base and a wider top, and which has a repeating modules of this. So 8 is a very unanimous number for the Chinese. So have everything at 8 floors or 8 modules. So everything was in 8. So it's a homonym with wealth. So that's the reason why it just has 8 modules in this. The 9th is the top shaft, suppose an architectural spire, and below that it have a repeated flared module. Now, the flare module has 25-story base shape truncated pyramid that provides the sort of stabilizing, that improved overturning resistance to the lateral stiffness compared to the straight shaft. That's the reason why we went for a pyramidal shape of the base, and it engages the perimeter columns. Also, the transition from the lower pyramid to the upper module is highlighted by the medallion. You can see that, and that is the representation of the ancient Chinese coin. This is what is a pagoda that was originally conceived. That's how it was. You can see the repetitive modules of that. Then, looking at the wind tunnel test, we felt that this was attracting greater moment, so this was not possible. Then we looked at bamboo. If you see bamboo here, you see the nodes here. This is very strong. It can withstand a high wind. If you look at this thing, from here we got an idea that the natural formation of the bamboo has revealed the unique structural characteristics of it. They provide a large foliage during its growing life and is quite strong and has a predictable support. And so from this we got an idea, and then it says, and we noticed that the bamboo is able to sustain tsunami and behave very effectively and efficiently in the lateral load. So with this, Taipei 101, we came up with this. You can see these are the medallion. Chinese represents the Chinese coin, and this is how it was shaped. This corner was sharpened. That means that is based on the wind tunnel test. So the final configuration of the tower is decided based on the wind tunnel test. Over this, you have a spire that is going about this, and below this, that is, you have 25 stories. This is the pyramid, truncated pyramid. Now, if you look at the wind has both static, dynamic, and aerodynamic effects. And in case of the stall building, in addition to the static, we need to consider both dynamic and aerodynamic effect, and it has and that plays a major role. So, to understand the behavior of the structure, I need to know the fluid mechanics, structural mechanics, because there is an interaction between the two, the wind flow. So that's the reason why we carry out the wind tunnel test, to understand whether what kind of a flow is there around the shape that we have generated. So based on the wind tunnel test, we can modify the shape. So as you know, the taller the building gets, probably the dynamic response starts to dictate your design. So, and then you can see that if you have a load, it can be broken down into two components. One is a static component, other one is a dynamic component, what you see here. So that again depends on the frequency of this fluctuating component. If the frequency of this fluctuating component coincides with the natural frequency of the structure, it can get into resonance. So we have to be careful in analyzing this. So when we have this, we need to analyze both across and along the wind effect, that is yawing moment, also to be taken into account. So I'm not going into details of all these things, just to give you that the factors A and B depend on the building geometry and turbulence environment. C is dependent on the building geometry, structural dynamic properties, mass, stiffness, and the drawn. Okay, how do I counter the wind? So probably you would have seen a coconut tree swaying in the wind. It sways, then it comes back, again sways in other direction. So that is because of the vortex shedding that happens around the coconut tree. The skyscrapers also experience the same alternating crosswind forces due to vortex shedding. Now, that means the wind that is passing through the object separates from the side face and the alternating whirlpools, and that exerts the difference in pressure, that pressure on the on the building, which makes it to sway. That means pressure on one side will be lower and the pressure on the other side will be higher, which makes the building to sway in a particular direction. So when you look at it in Taiwan, the typhoon of a 100-year return period, that brings in 43.3 meters per second or 97 miles per hour average over 10 minutes, the height of 10 meters. This can be similar to 3-second gust of 67 meters per second or 150 miles per hour. That's what I said earlier. That is the typhoon that you can expect in this. So this can excite a skyscraper, and the crosswind forces are much greater than the normally used for the design. So how do we minimize it, the effect of the crosswind? There are several approaches to do that. One is your orientation. Then you can create a setback and a varying cross section. This is what we have done in Burj Dubai. And then you can also create a twisting structure around that and introducing the porosity within this so that the wind effect, that the vortex effect can be reduced here. The other one is you can have a softened corner as you have it in Taipei. These are some of the approaches that generally adopted to minimize the crosswind effects. So this is a wind tunnel test where a crosswind around the chamfer 45 degrees corner reduce the lateral response. You can see this was the earlier response, and subsequently you can see here how the moment got reduced at the base. So this is effect because of the having a short tooth or a double notch corner. So this has brought a dramatic reduction in the wind moment. So that's how the shape got changed to this one. You can see here, this is what we have, the double-edged notch here. So the damping was about 1% of the critical middle sawtooth plants and 2.5 meter re-entrant corners at each corner. So with this, you could bring down the base moment. This is the typical 4-framing plan of the lower story. Then you have the framing plan of the upper story. This is the mechanical flow. You have the outrigger here. This there are different structural systems that can be used for a tall structure. Outrigger is one of them. There are other things also, and these outriggers are tied by the belt truss. That is a truss that you see that is going through like a belt. It tied them everything. Now, if you count it, there are 1, 2, 3, 4, 5, 6, 7, 8 columns here. This is called super column. The entire thing is carried on by this super column because 8 is a very holy number for the Chinese, Taiwanese especially. So they wanted everything in terms of 8. So this 8 columns now, we'll see how it is. So in order to minimize your interstory drift that could damage your package and the partition, the requirement was H by 200 for 50-year storm. And a large portion of the tower drift was created by overturning rotation of the lower story. So we had to control by increasing the column stiffness. So what we did was the hollow columns were filled with high strength concrete and they adopted as the core and the super column. So super columns are steel box they're built up to the level 90 there. Our steel plates are 50 to 80 mm thick and has a full penetration valve. And the box trap resists the bulging, rebar strengthens the concrete. And this box core, the super column, the filled with concrete, has a strength of 69,000 kPa, and the extra stiffness that is needed at the bottom at the basement level up to 62. This is again is determined based on your dynamic studies. That is how you say what is either I can increase the stiffness or I can increase the mass. But if I increase the mass, I'll be increasing my uh, seismic forces on that. So I can't play much around that. So by increasing the stiffness, automatically I'm going to increase the weight of the structure also. But I can arrive at some kind of a compromise that saying that, okay, I increase the stiffness to a certain extent, then beyond that, I will use some other device to absorb the energy of the either the wind uh, or the earthquake, either of the two. So we'll see how this was done. This is a section of the super column that you have. It has a stiffness around that, and you have the rebars coming out of this. This is the thing. Now, when it comes to the structural system, for the wind, I need a stiff structure so that I can reduce the drift. But if I increase that, I'm going to increase the seismic forces acting on it. So I need to come to a balance here. That means I need to check for the seismic ductility as well as the seismic strength when I do that. So what we did that each member that we had cannot introduce flexibility just like that, but because it is very harmful for the wind condition. So we use the open link of the beam to strengthen the side plate to maintain the stiffness. At the same time, the flexure of inherent strength, it has a large rotation that was anticipated during the seismic event. So this has the dog bone details of the proportion. Next is the occupant comfort. Probably this you won't study that in the regular building that we have. What happens is when the wind at the height of the tower increases, the upper portion tends to accelerate. When this tends to accelerate, people inside will feel very uncomfortable on this. So somehow this acceleration has to be reduced. So this is what is needed for the occupant comfort because steel being flexible, it tends to drift, and it has a very low inherent damping at about 1% of the critical damping and a moderate windstorm. So with the cyclic wind excitation, it can build up over the time. This could lead to the acceleration of the upper floor, and that can lead to reach a very uncomfortable level so that they may not stay there at all. So some kind of a damping is required to remove this kind of energy that is induced into the structure. That is through the wind. So how do I do this? So now the next thing is this particular site where the Taipei 101 is located, is situated, or it is built, is about 200 meters from the major fault line. It's not very far from that, and it is prone to the fierce wind and strong earthquakes. So we need to take both into account. So it has to be flexible in strong wind yet remain rigid enough to prevent a large side wave movement. How are we going to accomplish this? So what is the solution? So I can't make it flexible because again the building will accelerate and it may even break the glasses, the curtain walls, and other features. Now, the most of the design, that is, you can enlarge the critical structural element such as bracing, but height of Taipei 101 combined with the demands of its environment call for additional innovation. This is exactly where the sustainability call comes in. I just can't be increasing the space to do that. So now I have to look at the aspect of this. How do I do this? Now, take an example of a swing, simple swing. What happens now? This swing will keep on swinging. This will tend to twist because of the tree, depending on the motion how we are given, this can also twist. Same thing will happen in the case of a building. Now, if I push the swing, what happens now? It keeps swinging. Over a period of time, it comes to stop. What makes it to stop? That is because of the friction between the rope and the branch of the tree here. Now here, if the weights are all equal, probably it may swing. If they're not equal, it can also twist. It may not go in straight, but as shown in the arrow, it may twist. So this can happen to a building. So need to achieve the stability under violent motion, we have to design a gigantic tune mass damper. That damper is 5.5 meters across, that is, it is a sphere of 5.5 meters. It weighs about 728 tons, is suspended from 92nd floor to 87th floor. And this was designed by the Motioneering of Quebec, Ontario, the specialist in this, and it was done as a passive damping system. There are two kinds of damping systems. One is one is active, other one is passive, other one is a hybrid combination of active and a passive. Active system requires an external source of energy to activate it. So that is what is called as an active one. Passive one utilizes the energy supplied to it by the wind or the seismic force, get activated by that. Whereas the hybrid one is a combination of active and a passive. This we get more in the structural controls for the structural thing. So what happens now? So what happens is during the design wind events such as typhoon, the amount we can just say the amount of energy dissipated is so large, so accommodating that within the design is uneconomical. It's very difficult. Similarly, if I have to design the structural system for the maximum intensity of the earthquake, then the structure will become very huge, then it becomes uneconomical. So either way, I cannot accommodate that. Second, seismic design consideration is generally opposite to that of a wind, as the total energy dissipated is generally much than that for the wind. Now we have to look into this aspect also. Now, when you are dealing with this extreme forces and the displacement is a significant challenge for a damping system designer. He has to come up with a right design of a damper which would work in turn for the wind as well as for the seismic response. This is what we have, a tune mass damper suspended from the 92nd floor, comes down to 87. You have a viewing gallery here for the people to come and see that. This is what we call as the observation deck. Now you can see the chamfered corners here of the building. This what reduce the base moment. So by altering this, we could do that. And this is a truncated pyramid in a state. You can see that it is it's broader at the top, narrower at the bottom. That's how it is. This is the damper. So you can see the damper. This is 708 tons. If you include all the other accessories, it comes to 728 tons. It is suspended by 8 steel cables, and then these are 8 viscous dampers act like shock absorbers there. And the ball can move with a 1.5 meter in any direction and reduce the sway by 40%. 2 additional dune mass dampers of each weighing 7 tons installed at the tip of the spire, as you see at the top, and to provide additional protection against the strong winds. So this is how your damper looks like. So a pinnacle that you have on the top is also subjected to fluctuating wind. So it's likely to undergo fatigue in that this. So the first 3 modes that we identified are potentially creating significant stress during the storm. So we had to absorb the energy during that. So the dampers that we use was to absorb the stresses during the lower one. The disadvantage of the passive damper is I can tune it to one particular frequency. That means I will take one which is the critical one, I will have to tune it for that. Whereas in case of an active, because I'm applying an external force, I can tune it in a way I want. There is a difference between the two. So most of the cases what we have used here is a passive damper. So this is an example of the construction phase of the photograph of the construction progress from 1998 to 2001. You can see the site, how it has been done. All this thing, surrounding areas just green, nothing is being disturbed. Only within this area, whatever is being done has been shielded off from the other zone so that it doesn't have impact on the neighboring buildings. Okay. So I really don't know whether you can see this. Let me see. So when we were constructing this Taipei 101, it was hit by an earthquake. Can you see this? Is it visible?
No, sir.
Okay, 1 minute. I'll try to share that. So I'm sorry, it's not coming through. I'll pass it on to. So I'll pass on to. I think Manish has this.
Yes, sir.
So you can add on to this.
The image we can post it in the WhatsApp group, sir. We are having.
Okay, fine. I'll do that. Is the slide visible?
No, sir. Just gone. I think you may stop the sharing.
Yeah.
Once again, you present it.
Is it visible?
No, sir.
No.
Yes, sir. It is not
Visible now?
Now it was loading.
Okay, fine. Now you can see the photograph on this side. We had two cranes here, and this was being constructed. This is kind of earthquake that hit this sitting. That's what I've shown here. That kind of earthquake that you had. That is here. Your Taipei 101 is here. Sorry, is here. So it's about 300 meters from here. The epicenter is here. This hit this the site. What happened was, you can see the video later, the building remained intact, but these two tower cranes just fell off from this because they were not bolted to that. Otherwise, this wouldn't have fallen down. There would not have been any, there's no casualty as far as this is concerned, nor there was any kind of a thing on that. But only thing that happened was a damage to the upper portion of the structure here. This could be rectified. So this is how it was designed, that if it happens, certain portion get blown off, this can become, you can come and replace that. So this is what you see is the damaged portion of the structure. Next, after this, it was opened in year 2004 with a formal opening, but earlier it was opened in July 1st of 2003 by the mayor of Taipei. But later, that's the reason why we say that the period is from 1999 to 2004, or formally opened in the year 2004 on the New Year Eve. So There's another thing, sorry, I'm not able to show that. I will pass it on this. You can see the tune mass damper moving because of the effect of the typhoon as well as the earthquake that happened, which prevented the building from being collapsing. So this absorbed the energy for a whole 8 minutes. You could see that it was swinging. It was designed for a sway of 135, that is for a wind speed of gust of 135 miles per hour. Now the typhoon that hit was close to that, about 138 miles per hour. The whole damp mass, two mass damper started swinging, absorbing that energy. This is what we call it as a supplementary damping. That means I don't have necessary damping within my structural element. I add on something to it so that this will be a shock absorber for my building, which protect my main primary frame. So this is about it. Understand one thing, road to success is never straight and smooth. All it requires is the courage and the attitude to overcome the obstacle. The supreme art of the teacher is to awaken a joy in the creative expression of the knowledge. This I learned from this great gentleman, Sadhguru. Only those who dare to fail greatly can achieve greatly. This is what John F. Kennedy said. So thanks. Thanks for your time and thanks for your attention. I hope I'm on time.
Thank you very much for your good speech regarding construction of multi-story buildings or towers like this. So I think you have shared your practical experience during your profession. Sir, regarding this, some of few people have addressed some queries regarding this.
Yeah.
Yes, sir. So I like to read the first query. One person, Divya Sindhu, has asked, what are the wind forces acting in tall buildings?
What are the wind forces? What are the wind forces? The wind forces are basically from the climatic condition of that place.
Yes, sir.
The wind forces is only one. It can't be many.
Okay, sir. So based on this, I want to ask one query.
One second. It depends on the direction of the wind. You have to find the angle of attack of the wind, and then you have to choose what is the worst direction of that, which would have a harmful effect on your structure. Okay, so based on that, probably you would have heard about City Corp building in New York. When Lee Mercer designed it, he found that an intern told him that the building is not safe against the wind. He was puzzled, but then he started working on his mind. He went back to Devonport and checked with him, and he found that what the intern said was right. Then he had to he had to strengthen the structure without telling anyone that this is not safe against the wind. So wind basically depends upon the angle of attack, basically, and also on the wind climate around that zone. There is only one type of wind. Again, you have static and the gust component. Gust is the dynamic effect of the wind. That you have to consider separately. Yes, sir.
Yes, sir. Thank you, sir. So based on this query, so I would like to ask you that you have said that while accessing the wind forces, there are two things needed to access that. One is structural mechanics, and another one is fluid mechanics regarding wind forces. Sir, I want to know that in what way the knowledge of fluid mechanics will help in wind study for this high-rise towers, sir.
See, wind can be approximated as a fluid flow. See, generally what you have studied in the fluid mechanics is the flow around the streamlined body. For example, aircraft. It is the flow of the air around the streamlined body. Okay. Whereas your civil engineering structures is a block body. It's not streamlined. It's going to stop the wind, so it's going to experience greater forces compared to that. So you need to have an idea of how the fluid flow around a block body to understand the wind effect on the structure. If you take a master's course in wind engineering, the first thing you study is about the fluid dynamics and the fluid mechanics. Now you have computational fluid dynamics that helps a lot in understanding the behavior of the interaction between the wind and the structure.
Okay, sir. Sir, the next query. This is from a participant named Umesh. What is the limit of story drift for tall buildings?
It decided by a governing criteria, generally H by 500. If you have to limit it to it, you have to see. That's the reason why we have used damper. In order to, more than the limiting the drift, it's an interstory drift that causes the harm to the structure. We have to reduce this. So again, it depends upon your structural framing system that you have adopted for the tall structure. It dictated by your local condition. Like for Taipei 101, we went through the record and then we decided on, as you saw, that 100-year return period of the wind, so that we could foresee some of the things that could happen. Generally, if you design for 1 in 50, maybe we would have not been able to see that. But with this, we were able to foresee some of the things with that. So again, it depends upon your local condition and the local, what is called the codal provision that is there. There in Taipei 101, we didn't have many things. We didn't have codal provisions. We did some kind of an experiment to justify this, and then we presented to the committee. So some cases you require certain things like that. Yeah.
Yes, sir. So the next question is, top-down construction, is it being practiced in India?
Yes, very much. The building opposite to Indian Express, I forgot the name of that building. It is built top-down. Your number metro at certain places is built top-down. There are many buildings in India being built top-down.
Yes, sir. The next question, can you throw light on wind tunnel testing?
What exactly they're looking for in wind tunnel testing? Okay, basically, wind tunnel test is to see certain things I may not be able to assess using the codal provisions and other things. So I want to carry out the test on using or simulating the same wind condition in a controlled environment to see that what kind of stresses will develop, how the moment will develop, how the structure will behave. So I create a model of my building in the wind tunnel and then subject it to that kind of a wind force from a various angle, and then I measure the quantity that I require. If you get a book on wind structures by Peter Sachs, that's a pretty old book, and there's also a book by Holmes, J.D. Holmes. That will give you more information on the wind tunnel testing, why it is done and how it is done. Probably if you go take up a Peter Sachs book, that also gives you some elementary idea about fluid mechanics, and then ties it up with structural engineering and how the wind plays a role. Probably you can look into that. That will give you some idea about it. Different ways to measure the stresses induced at the various points in your structure, and also the base moment. Basically, just to confirm that whatever you are doing is correct. Suppose I want to come up with the tune mass damper for that. I will carry out the test and check how does my this thing behave with this. So I need to carry out a wind tunnel test on that.
So the last question, what challenges you had faced in Petronas tower construction?
Petronas tower was relatively easier when compared to Taipei 101. But yes, we did face some challenges. because none of us in the beginning were familiar with the concrete, in the sense we had never used concrete for a tall structure. That was the first. And then we learned to use this for a high strength concrete there. And then it's a composite construction, which is similar to this. The major challenge was in the sky bridge design, where we had to alter the design. Earlier design was a cable supported sort of thing, which was not feasible because it could sway in the wind and get twisted. So we had to change the design of the sky bridge connecting the two towers. Erection of the sky bridge was a challenge because a lot dependent on the weather conditions there while erection, and we faced a lot of challenges during the erection. Apart from that, it was the initially, yes, when the site was chosen, the site was not okay for siting this tall tower because there was a dipping cliff underneath this. If you had built it, probably it would have leaned by now. So we had to shift the building about 60 meters away from the original site. For that, we have to carry out the geophysical investigation to find out the subsoil strata, how it is and how good it is to take the load. So under that, we have calcite rock, which is all the piles are embedded into the calcite rock over there. So apart from that, it's not that challenging when compared to Taipei 101 because Malaysia is relatively, the Kuala Lumpur does not experience that kind of a high gale or a seismic activity compared to Taipei. That's one major difference. The wind forces there, that is the wind speed that we get there, is not that high compared to that of a Taipei 101. But yes, it does experience some gale storms like that. But the speed is not that high as that of a Taipei 101. So that way it was relatively easier.
So another two queries which came now, sir.
Okay.
What is the role of shear wall during stability failure?
Stability failure. What is stability failure? Okay. I don't know what exactly they mean by stability failure here.
Yes, sir.
Shear wall is basically, see, if you look at the framing system for a tall structure, we have a system for the gravity load, a system for the lateral load. Now, the perimeter column, sometimes what we have in Petronas as well as in Taipei 101, the wind forces, that where you have the outrigger and the belter. They carry the forces and then feed it to the core shear wall there. They predominantly carry the lateral load. They get, that is like, it's like just if I pour water at the edge, I have the drains which take this water from the outer towards the shear wall, like this, everything that flows towards the shear wall. Just an example, just to show that how the forces flow. So that will act as a lateral resistance system. That means basically how I tie it. Now, generally, if you are looking at a stability failure, it's about the concern about the stability of the structure as such. You have different kinds of steel frames, like braced, unbraced frames, and most of the cases, it is you have a braced frame where one member will be in tension and one will be in the compression. Member which is in compression is likely to fail by buckling. Okay, but there are frames, that is buckling restraint frames, available or can be designed so that this kind of failures can be avoided. Now, shear wall will not fail by stability in the sense it's not subject to that kind of a forces. Probably, if you look to this, the other way of overcoming this is that you can even go for a composite shear wall. That means I have a steel plate and a concrete. This can also act as a damper in this, both the cases. So I can do that, but I don't understand what they mean by stability failure of the shear wall. I'm not very clear about it.
Yes, sir. Sir, one more last question, sir.
Yeah.
Can shear wall will act as dampers?
It cannot have act as a damper. Even if you take 5% of the critical damping, it may not be enough to dampen the whole thing. Yes, it will contribute, but not to that extent. You may not consider that if you take a shear wall, even considering the size of it, it may not be that effective in reducing the vibration of the or the drift of the tall structure. See, in some cases, you have used dampers within the primary framing system itself. Like we have a viscous damper or a friction damper. That is, when you have a brace frame or chevron brace frame, in that case, I can use a damper within this at different levels. That is called the multiple levels of damping. I can use that. But never in a shear wall. If at all I have to use it, probably one way can we think of is the composite shear wall. That can be done.
So, thank you very much, sir.
Yeah.
Thank you very much for your nice presentation and kind patience to clear all the queries. So I thank you once again. So on behalf of this FDP program, with respect to participants and our faculty members of BMSIT, we thank our Dr. Aravind Bhashyam to deliver the expert lecture today on case study of Petronas Towers in Taipei 101. Thank you, sir.
Thank you. Thanks for giving me an opportunity to talk on this. Thanks a lot
Yes.
for this.
Yes, sir. It's our pleasure, sir. So I would like to address the participants. So day 2 will commence by tomorrow morning by 10:15 a.m. The YouTube link will be shared by tomorrow morning around 10:15 a.m. and you can log in within 10:30 a.m. for further participants. So thank you all. Thank you very much. And I would like to thank one of my coordinator and my friend Professor Manish Shashikant Darik for his effort taken for live streaming in YouTube for the past 2 days. So on this venture, I would like to express my sincere gratitude to Manish for being because as you know that in the beginning itself I have introduced that the number of participants in this program was very large. The registrants itself around 650 members. So we have planned to go for live streaming in YouTube. So I thank Professor Manish for doing that to become real now today. So thank you, Professor Manish. So now we'll wind up the session.